Okay, in the last video we talked about what a translation, rotation, and reflection are. In this video we're going to actually look at how we would do that using the XY coordinate plane. So we're going to be graphing a bunch of points today. Alright, let's look at this first example. We're going to graph A, B, and C. We're going to graph 5, 6, -7, -1, and 4, -3. So let's do that. 5, 6 would be 1, 2, 3, 4, 5, and then up 6. 1, 2, 3, 4, 5, 6 right there. Alright, so we'll make a little dot there. And that's our A point. Alright, oh, not prime, just A. Whoopsie. Okay, so then for B, we go -7, -1. 1, 2, 3, 4, 5, 6, 7, 1. There's going to be our B. Didn't work out so well. Let's try that again. There's a B. Okay, and then C is 4, -3. 1, 2, 3, 4, down 3. There's our C. Alright, so what this is saying right here, the P of xy equals x minus 3, y plus 4. This is saying you take every xy and you subtract 3 from the x and add 4 to the y. So let's do that with these numbers up here. We have 5, 6, so we're going to take 3 away from the 5. So 5 minus 3 is 2. And then to the 6, we're going to add 4. So 6 plus 4 is 10. So our A prime, our new A point, is going to be 2, 10. Okay, let's do the same thing for B. We're going to take -7 and take away 3. So -7 minus 3 is -10. And then -1 plus 4 is 3. So our B prime is going to be -10, 3. And then lastly, our C, we take 4 minus 3, which is 1. And we take -3 plus 4, which is also 1. Alright, so let's graph these 3 points. And I'll do this in red. And actually, before I do that, I want to connect A, B, and C. I'll just connect it with my line tool here. So we're going to make a triangle. And then let's graph A prime, B prime, C prime, and let's do that in red. So 2, 10, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is going to be right here. And that's going to be A prime, so let's put a little A prime there. And then B prime is -10, 3, so -10 up 3. And then C prime is 1, 1. Right, and let's connect these, and I'll connect them with my line tool. Actually, let's do a little bit of finagling here. We're gonna make this red just so we can kind of see the. There we go. All right. So we've got our. This is our image, the black one. I'm sorry. Let back up. This is our pre-image, the black one, and our image is what we ended up with. That is the red one. So, what happened from the pre-image to the image? So, it looks like everything just shifted up and to the left, and that's a translation. So, this stuff we did here was a translation. And then we need to figure out, what do these numbers do? The -3 and the +4, what did that do from C to C prime, and from A to A prime, and from B to B prime? So it looks like from C to C prime, it's back 3 and up 4. And same thing for A, it's back 3 and up 4. And for B, it's back 3 and up 4. So it looks like if we do a -3 to the x, that moves it to the left 3. And if we do a +4 for the y, that moves it up 4. And so the translation is if you add to the x and add to the y, or subtract to the x and subtract from the y. So this is a translation. Translation. And we would say it is left 3 and up 4. All right, so that's our first example down. We've got a few more to look at. So let's look at the next one. Same 3 points, 5, 6, -7, -1, and 4, -3. So let's graph these. 5, 6. There's our A. Our B is -7, -1. And our C is 4, 3. Or 4, -3, pardon me. Okay, and we'll connect those. So we got our triangle. This is our pre-image. And now we're going to figure out what's our image going to be. So this one we'll do in red again. What this is telling us to do is we actually take the x number and we make it the opposite. This minus sign here says make it the opposite. So if it's 5, 6, the y stays the same, so it's still going to be 6 for the second number. But the x is going to be -5. Okay, just take the opposite of the x. So instead of -7, -1, it's going to be +7, -1. Instead of 4, -3, it's going to be -4, -3. Okay, let's graph this and see what this looks like, see what kind of transformation this is. All right, -5, 6. 1, 2, 3, 4, 5, 6. B prime is 7, 1. Or pardon, 7, -1. And C prime is -4, -3. There we go. Okay, so we'll connect these. Whoops. And then this diagonal one. Alright, so the question is, which type of transformation is this? So it's not a translation. It didn't just slide from one way to the other. It didn't go up and down or left and right. It actually flipped. It flipped over this line. So the A flips over here, the B flips over there, and the C flips over there. So this is a reflection. And then once we figure out what it is, we got to say, well, where did it reflect over? So it's a reflection over, and then it looks like it reflected over this line right here. And this line right here, that's the y-axis. So if we do the opposite of x and keep y the same, that ends up being a reflection over the y-axis. All right, let's look at another example. And this is just like the previous one, except the x stays the same and the y becomes opposite. So let's graph these again. 5, 6. 1, 2, 3, 4, 5. Up 6. -7, -1. Oops. And 4, -3. Okay, so let's label these. This is A. This is B and C. We'll connect the dots to get our triangle. 1, 2, 3 lines. Okay, so here is our pre-image, and now let's figure out our image. We'll do this in red again. So the x stays the same, and now we do the opposite of y. So it's going to be 5, -6. And then -7, +1, and 4, +3. All right, let's graph these. 5, -6. That's going to be our A prime. -7, 1. That's going to be our B prime. And 4, 3 is going to be our C prime. Okay, and we'll connect these dots with straight lines, of course. Let me use my line tool. There, that's better. And I'll highlight these and make them red again. Okay, So our pre-image is the black one, our image is the red one, and it looks like what happened was everything flipped across this line. The C flipped up to the C prime, the A flipped down to the A prime, and the B flipped up to the B prime. So this is another reflection, and this one is going to be a reflection over the x-axis. Okay, so if the x stays the same and the y is opposite, then it's a reflection over the x-axis. Okay, let's do them both at the same time. So we're going to make the x and y opposite. So, same thing. Let's graph these quickly. 5, 6. I'm getting pretty good at this by now, I think. Here's the first one. -7, -1. Fourth, -3. Whoops, didn't mean to click that. So this is our A, this is our B, and this is our C, and I have some extra lines here I don't need, so I'll erase those real quick. And let's make the lines. Okay, 1, 2, 3 lines. Okay, there's our pre-image. So now let's figure out our image. We'll do this in red again. So now we're just going to do the opposite of x, which would be -5 and -6. It's opposite of y. We do opposite of -7, -1, so that would be +7, +1. And the opposite of 4, -3 would be -4, +3. Okay, let's graph these. -5, -6. This would be 7, 1. And -4, 3. Okay, and we'll graph, or we'll connect these dots with a line. Okay, and make sure that they're different colors so we can distinguish between the pre-image and the image. There we go. So this one, what it is if we had a -x, that was a reflection over the y-axis. If we had -y, that's a reflection over the x-axis. So you could say it's a double reflection. It's a reflection over the x and then a reflection over the y. But it's also, if you take this black shape and rotate it 180 around the origin, it's also a rotation of 180 degrees. So let's say that one. This is a rotation around the origin of 180 degrees. So we've come up with 4 different rules. We've got -x is a reflection over the y-axis, -y reflection over the x-axis, and if you do -x and -y, it's a rotation around the origin of 180 degrees. Okay, last one here for the day. What we're going to do is flip the x and the y and see what happens there. So, same procedure, 5, 6. -7, -1. 4, -3. We'll label them A, B, and C. Okay, and I'm not going to connect them this time. We're just going to see where the dots end up. So now this time, we're just going to flip. Instead of writing x, y, we're going to write yx. So that means now instead of writing 5, 6, we're going to flip them around. So it's going to become 6, 5. And instead of -7, -1, it's -1, -7. So this is saying put the y where the x was and put the x where the y was. So we end up with -3, 4. Okay, so let's plot these points in red. We get 6, 5. That's A prime. We get -1, -7. That's B prime. And we get -3 up 4. That's C prime. So this one is kind of tough because, it's not a rotation because the A would rotate just a little bit and the C needs to rotate a lot. It's not a reflection up and down or side to side, but it is a reflection. This one's actually a reflection diagonally. So let me draw in this diagonal line. Yep, just like that. And so it is a reflection over this line. The A reflects across there, the C reflects across, and the B reflects across. So this is called a reflection across the line y equals x. The line y equals x is this diagonal line that goes through 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. That's why y equals x whenever x is 5, y is 5, and so on. So we looked at a few different rules here, and here's a summary. If you add A and add B, that's going to move it A units to the right and B units up. And then if it was minus, it would move it to the left and move it down, depending on this is plus or minus. If it's minus xy, that's a reflection of the y-axis. Negative y is a reflection of the x-axis. If you do opposite x, opposite y, that's a reflection over both x and y axes. It's also 180-degree rotation. This is going to be, oops, pardon me. This is going to be the one you want to focus on. It's a 180 rotation is this. And then the last one, if you flip the x and the y, that reflects over the line y equals x. Okay, so that's it for transformations in the coordinate plane. I guess that's the end of the hour.